Hello, everyone. How's everyone doing today? We have a little friend here who wants to join in and lead the stream. We'll see if we survive today with him here. All right. So last time we didn't finish the second day of Advent of Code, so we can try to resume that today and try to kind of debug it and figure out what's going on. So as a reminder, we're doing the first part of the day 2, the gift shop, where we need to figure out the codes, the product codes and whatnot. And something's wrong with the logic. And we wrote quite a not fun query in SurrealDB. And where was it where I noticed? Because I was kind of looking through it, and we had a situation where I believe for the right side, I was looking at the wrong spot. This was from, and this should be to. So just with this little thing, I'm gonna copy it, paste it into here, and see what happens if we get any sort of different result. Just in case, because maybe we were that close to the solution, but no, it's not. And it doesn't tell us if it was more or less. Okay, at least 5 minutes before trying again. All right. Yeah. Okay, so the nice thing is that here we kind of have a bunch of examples that we could run, like, encode and see if we actually solve them correctly. All right, because for those examples, we have actual result. Let's see if we're off a lot, if we're off a little bit, and we can kind of debug for every single one of those to see, if we're doing well or if we're doing something wrong. Let me adjust things here. Okay, I should be able to see everything now. Yeah, all right. YouTube Studio is having some weird issues today. All right. So we can literally, maybe I'm just gonna plop it here for now. And we can kind of copy paste our, let's actually grab it from here. We go to the input, we paste it here, and we just replace everything. What just happened? 11 to 22. 95 to 115. 998 to 1012. Now this is not comma. 1188511 and 80. Hopefully I'm typing correctly. Mm-hmm. Okay, and the last one. Okay, that should be it. So this should be our input. All right. So, wait, why do I have this thing here? Okay, now it's correct. So let's go here and replace our input and see what is the result we're getting. We just need to remember that we need to delete our hit table. We can actually probably do it here. Remove if exists table hit. Or remove table if exists hit. There we go. So now we run this, and our result is 122.777.666.4. While this is suggesting one two two seven seven seven. Oh, instead of this one has 5554, we get 6664. What? That is a interestingly similar number. Just off by 111. What the hell? Okay. What is in our database now? For each hit, for 11 to 22. Okay. We've got is different length? No, because they are correct. Max pattern digits, 1. Yeah, because pattern of 2 would be wrong. Pattern length, ranges to generate from 1 to 2. Which means that both 1, 1 and 2, 2 should be correct. Length, repetitions. So we have the hit for 11, and we should have the hit for 12, for 2 and 2, right? There we go. That's exactly the same. So that's good. I think we can actually make the debugging a little bit better. Just a little bit better. So let's actually edit it in here. So when we are saving our, because here we're basically absorbing the hits, okay? So let's just do that. We're gonna have debug hit. That'll be like another table. And this other table is basically whenever we have a hit or not, we will basically log it. So where can we do it? Handle same length, blah, blah, blah. It's right here, where we basically go and generate every possible sub pattern for every range, okay? That means we can probably do something fun. So this is the range, and this is the potential hit, as in the repeated pattern as a number. So let's split it up a little bit. Let potential hit a string, and that's going to be this part. Okay, we just don't convert it to integer. So we'll do. There we go. So we save it here if it is in range. But before we do that, I also want to save just overall everything about this specific hit. So let's do something like and we'll call it debug hit ID, and it will be, yeah, type thing will be debug hit, or let's just do it like this. There we go. That looks nicer without the underscores. And we need to also provide the value. And how can we quickly make it as a reference? I guess we can just make it where we do, because we'll want to look it up quickly. via some kind of filters. So maybe we actually don't give it the ID. All right, we're not gonna give it an ID. It's just gonna dump them there and that's it. So instead we can just do in whatever create debug hit, and we're gonna set a few things. We want to set the from, which will be at this point. What is it? Range is from here to here. No, we want the pattern definition, right? Pattern definition from to. Pattern definition from. Then we're gonna have 2, which will be pattern definition 2. And the only thing left now is the actual generated thingy. So I guess in here we can just range. In pattern definition, what did we have it here as range existing? Range is, oh, we're just noting the range. Okay, I see. We don't need that. Okay, so we don't need the range. We need the potential hit value and as a string. Okay. Pattern definition and definition entry. We're going to put those 2 in here. Why not? This we're going to have a full set of data to just know everything about what there is to know with this very specific debug hit. The only thing would be, I guess, is it in range or not? So let's make another variable. Let is in range. And that's going to be I wonder if we can just do this. I mean, logically, I guess we should be able to do this. And therefore, in range, or more like is hit, as is in range. Okay. And therefore here will be if, will be a little bit more readable, is in range. Then we're gonna do stuff. Okay, so this should clear both tables before we start. So let's try to run it and see what happens. Okay, it counted the same thing, so our logic didn't change. But now in the Explorer, we should have a debug hit with how many records? Just 20 records. There we go. What we have from, to, and if it's hit or not, and all the details. So in this case, we can look at 11. We have 2 11s. Look at that. Oh, that's from the from. So we can sort by from, right? And we have our range from 11 to 22. I don't think I can reorder them. Okay. So one was generated 11, and we can see it generated that. Okay, that's great. And 22 was generated as well. So this particular range is fine. Now let's look at 95 to 115. 95. Look at that. We generated 2, 99, and 111. So why does it say that 111 is not correct? It's 3 repetitions. Unless it can be only twice. Since the young elf was just doing silly patterns, you can find invalid IDs by looking for an ID which is made only of some sequence of digits repeated twice. Oh. only twice. We don't need to try do it 3 times or whatnot. Oh, that changes things. All right. Well, I guess our code is now overcomplicated. Where's the code here? That's fun. So in that case, max pattern digits, and somewhere there we had evaluation. Prep list of ranges to generate repetitions to test. So already at this stage, probably we can figure out that, hey, we just need to make sure that the patterns generated are only the length of 2. So we have the ranges, okay. Ranges generate, repetitions left, handle different lengths. And repetition right, right. So we want the repetitions to be only 2. Repetitions right is larger than, yeah, there we go. So not larger or larger than 1, it needs to be exactly 1. You can just do single here. And the same thing here, it needs to be exactly 1. And for repetitions here, repetition needs to be equal to 1. And now when we run the query, nothing happens. We have no answer. Wait, not 1. It needs to be 2. Silly me. 2 and 2. There we go. Run the query. Now we have the answer. And the answer is correct now. Okay. Oof. So that means we can temporarily comment this one out and put the real input in, which we have saved here. And run it again. And now we have completely different thing. Let's see if 5 minutes have already passed. Submit it. And now it's the right answer. Okay. I didn't read things correctly. That's the whole problem. All right, let's see what's the part 2. Maybe part 2 is that, hey, repetitions can be more than just twice. All right, part 2. The clerk quickly discovers that there are still invalid IDs in the ranges in your list. Maybe the young elf was doing other silly patterns as well. Now an ID is invalid if it is made only of some sequence of digits repeated at least twice. Oh, there we go. So 1, 2, 3, 4 twice is wrong. Or 1, 2, 3, 4 3 times, or this thing 5 times, or just 1 7 times. Perfect. They're all invalid IDs. Okay, so now we're talking. Now we're getting to the solution I started with. Okay, I guess let's just do this. All right, we're gonna select all this. And let's first, though, comment out the debug hit. We don't want it right now. So this is purely for debugging. This can stay. Performance-wise, it's not a big deal. Great. So the same thing. This can stay. It will just always wipe the table. No big deal. So let's grab it. And let's just make sure that we paste it over here. And yeah. So that's basically our first solution. And now let's create to the second solution, which should be very, very similar. In this case, we're gonna go over the equals 2. There we go. And replace it with, what was the repetitions left is larger than 1. Okay. And here we have again. Can we just do this? No. Change to larger than 1. And larger than 1. Paste it here. Right, there we go. Run the query. This is the result. That's correct. There we go. We solved those two. Oh, all right. So let me just push those changes. We have those 2 files, right? So we can basically do finish day 2 or 1 and 2. Okay, there we go. It's all up there. Committed. All right, I have info and I'll be finishing in an hour, so we will see how much we can do. All right, wait, did I push it? Push. The first, really? Oh, I might have. Oh yeah, I updated the links. Okay, there we go. Cool. So in the README, we can say that we completed and well, we're gonna start with challenge 3, part 1, incomplete, because I am expecting that we're not gonna complete it here yet. But okay, so let's look at the number 3. All right, day 3, lobby. You descend a short staircase, enter the surprisingly vast lobby, and are quickly cleared by the security checkpoint. When you get to the main elevators, however, you discover that each one has a red light above it. They're all offline. Oh, great. Sorry about that. An elf apologizes as she tinkers with a nearby control panel. Some kind of electrical surge seems to have fried them. I'll try to get them online soon. You explain your need to get further underground. Well, you could at least take an escalator down to the printing department. Not that you'd get much further than that without the elevators working. That is, you could if the escalators weren't also offline. I mean, you can walk down the escalator. What the heck? But don't worry, it's not fried. It just needs power. Maybe you can get it running while I keep working on the elevators. There are batteries nearby that can supply emergency power to the escalator. All right, for just such an occasion. The batteries are each labeled with their joltage rating. Okay. Joltage. That was from 2020. Okay. A value from 1 to 9. You make a note of their joltage ratings, your puzzle input. For example, 99765321111. And all those fun little lines. Okay. The batteries are arranged into banks. Each line of digits in your input corresponds to a single bank of batteries. Within each bank, you need to turn on exactly 2 batteries. The joltage that the bank produces is equal to the number formed by the digits on the batteries you just turned on. For example, if you have a bank like 1, 2, 3, 4, 5, and you turn on the batteries 2 and 5 and 4, so this one and this one, the bank would produce 24 jolts. Oh, okay. You cannot rearrange the batteries. All right. You'll need to find the largest possible joltage each bank can produce. In the above example, in 98, blah, 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 you can make the largest joltage possible of 98 by turning on the first 2 batteries. In this one, we can do 89. Okay. We can make this one to be large as 8 and 9, producing 89 joules. All right. And this one is 78, of course, and whatnot. Okay. In here, the largest voltage you can produce is 92. Okay. The total output voltage is the sum of the maximum voltage from each bank. Okay. So in this example, the total is 98 plus 89 plus 78 plus 92. Okay. There are many batteries in front of you. Find the maximum voltage possible from each bank. What is the total output voltage? Of all the ones that we get? Wait. There are many batteries. As in battery banks? Get your puzzle input. Okay, so these are each battery banks. And they're all together. Each basically will add up. Okay, this is relatively simple. So let me literally grab this input so that we have it. And let's create a new puzzle, which will be day 3, part 1. SurrealDB. Okay, and we're gonna do, what was it? Let input is something. Okay. Go away. Let input is, and we can just paste this whole thing. Holy moly. There it is. We've got our input pasted in. How beautiful. Now basically we need to figure out the algorithm for how to actually solve this puzzle. Because there's no way we're just trying all the possible combinations. There's just no point. Okay? So what needs to happen is we need to kind of find, because the numbers, the output numbers, whatever, how do we have 2-digit numbers, right? How large it is will be like one from the other will be always told by the, I don't know, largest first digit. So if we have two numbers to compare, I don't know, 79 and 97, we know that 9 is always larger than 7. Therefore, the moment the first digit is larger, we know that this is the best possible solution, right? The only problem that shows up if we have, I don't know, 91 and 92. Only then we need to check the second digit. So what I'm thinking is, what if we can scan all this and basically find the largest digit and all their indexes? Like, where are the largest digits? Like, which is the largest digit we can find? So in this case, we're going from left to right. 4, we just, let me literally just, let's do it. We're gonna create an example out of, I don't know, I don't want that long number. I'm gonna zoom a little bit more. And let's do 1, 4, 3, 2, 2, 1, 4, maybe 7, 8, 4, 1, and 7, 1, 9. Okay, this will be our number. It's pretty long, but not like super long. So the way I'm imagining the algorithm is that it's gonna keep track of something like largest number, right? So let's say we start 0 is largest. We know that 0 is invalid in this case. And I don't think we have any zeros in the first place. Yeah, there are no zeros. There are no batteries labeled 0. So that's good. So 0 is the largest. Yeah, that's it. 0 is the largest. And we always read them from left to right. Okay. So something tells me we just find the largest number that's all the way to the left. The most leftist largest number. And then we search for the largest for the second one. Yeah, I think that's what we can do, like 2 separate just scans, which should be relatively fast. So we start by this. We find the first character and we select, oh, 1 is the largest, right? So we just do that. We go here. Oh, 4 is larger than 1. So we remember, well, 4. Then 3, nope, that's smaller than 4. Smaller, smaller, smaller. Same, we do nothing. 7, oh, this is nice. This is larger, so we replace it with 7. Because this will produce the largest possible number. 4, 1, 7 again, and at the end we have 9. But this is the last digits. That means nothing can be on the right of it. Therefore, we won't be able to do much. So we just discard that. So we go to where we found that first 7, which was here, and then search for the other one. So is first digit, and whatever else will be the second digit. So we find a 7, and okay, we remember 7. This is small, small equals smaller. 9. Okay, this is largest, so we note 9 is the second digit. And this is like so therefore 79 is the number that we can get out of here, which is largest. And I think that should actually solve the whole thing. Just look for those. So we need to remember what is the largest number and its first index for the first loop. For the second, just find the largest number. 9 is already the largest, so after that, we don't need to scan. And yeah, that's it. So yeah, let's get to it. First of course, we'll need to kind of make this whole thing into lines that we can process. So we can just simply replace, making those strings and then those strings into arrays of digits. I think so. We can just straight up go with digits. We'll store arrays of digits. I believe the first day is where we had like the most simple, yeah, there we go. Where we're simply scanning. So initial value to 50, extract. So we took the input, split it by this, and that's that. Well, maybe this will be good enough too. Yeah, we split it by something and then map it. There we go. I'm just gonna copy this, and in the new thing, we're gonna say, hey, take the input, split it by this thing. And then we basically, so let's say we need to convert each line into an array of numbers. And that's it. So we split it by line. Then we're gonna say, and of course this is not pattern defs, this will be battery banks, okay? Because each line is a battery bank. So then we'll basically say bank string, because that's what we're having. We split that, so each line that we get is just a string. And we need to kind of convert it. So what we can do is bank characters, which will be, oh no, we just say digits will be. And we do bank string, split it by just characters. So we end up with, now we have an array of what do you call it? Of digits. So after that, we can map it again into, or we take each digit and we return integer of digit. And that should be it. And we just return digits. Okay. So we don't need this. We don't need this anymore. This is our map. Yeah, I think that's it. So let's just clear our data, configure it, please, and always, where is it? Default lifestyle, default table. No warning. There we go. So this thing, run a selection. Let's go here, paste it, and I want to just return the battery. Thanks. And we should have a, oh, cannot convert this into an integer. Expected integer, where? Strings. Digits is this. Bum, bum, bum. Something is not happy here. I don't think this will help, but won't hurt to try. I mean, the syntax highlighting changed, so maybe. Nope. Of course not. Why would it? Let's just try to do that. We're gonna get rid of this and let's see what happens. Now we get a list of those. Oh, the first character for some reason is always empty. Why is that? We don't have anything else here. Why is that? We already got rid of the like new line and whatever. We don't have any spaces. Let's see if we have some function like trim or something for the string. Database functions, string functions, and do we have trim or something? Place, reverse slice. Trim removes white space from the start and end of a string. There we go. So we can go here and we split it. Each entry is bang string.trim and then split. And no, the split just produces it no matter what. The first character is empty for some reason. I see. Okay. What we can do is just say 0, right? Gosh, that overcomplicates stuff like unnecessarily. And the last character is the same thing. Okay, I see. So basically, we would need to apply a filter before we do stuff. We could, right? We have the split. Then we're gonna do, is there a filter or something? I recall there being a filter. So this will be in array functions. We should be able to do something like filter. Filters out values that do not match a pattern. So filter true or filter Okay, filter something that's not empty. So filter character, or character is not this. And therefore, when we run this thing, we should, I mean, we don't need the trim anymore, because that is already trimmed. There we go. We don't have anything at the beginning, at the end, and we can map it into integers. So we just, whoa. There we go. All right, we've got it. We have just numbers for each thing. They're all ordered because it's just a normal array. So let me copy this, and we're gonna replace it nicely here. Okay. So this means that we have our battery banks as logical digits. And that's relatively simple to process. So now we need to implement our algorithm that will basically, for each line, go through that and find it, right? Return some largest this and that. How can we do that now? Because the problem is that we don't have the, what do you call it? We don't have the ability to override some kind of override a variable currently. Maybe soon it's gonna change, I don't know. But we don't have that functionality. And that means that we can't just say let something and then in a for loop just keep updating it. We can't do that. So we have two choices here. We either, every time we find a better number or something, we kind of update it in some temporary record on the database. That's one option. The other option would be that we find some kind of function that would just find as the, index or indexes of that specific digit. And we just run 10 queries over that. But I think to keep things relatively simple, we can just do the saving in the database. This is not a lot of data. This will just execute it quickly, especially that once we find like something like 7 or 9. I mean, if it's 9, we just can stop the loop because we already found it. So that's good. So yeah, let's just loop over it. All right. So what we can do is, I will literally map over each battery bank. So let's say let joltage, or like joltages, because that will be a list of joltages for each battery bank, or will be battery banks map, and therefore we have a bank. That's our variable, and we can go over them here. So we'll kind of iterate over the battery banks and figure out what to do next. Here, let's just do it this way. There we go. Okay, so we've got our bank. So now we need to kind of set up the variables that we'll be using. So we need to set that we need to keep track of our first digit. So let's do, not update, it was upsert. And let's do temp first digit. Okay, our first digit will be, let's just call for the first. Just temp first will be our first digit. We set 2 values on it, which will be the digit, which is 0 initially, and then index, which is 0 initially, or like -1 to start with. And there we go. That will be our first thing. Then we do upsert temp second. And here we don't even need to track the index, it will be digit, which again is 0. So now that we have the values to track, we can set up the loop. So we'll basically iterate for each digit in each bank, because each bank is just an array of values. We can, by the way, I don't need this. We can simply do what do we do here now? For each digit. So if the digit is larger, we do this. If it's not, we do something else, right? So let's say if digit is larger than currently max digit. There we go. So we set those values, but for each iteration, we need to read it first, right? So let current value or current max is what? Select value, or like digit from only temp first. Okay, so this is our current max. If the current digit that we're iterating over is the whatnot, come on, larger than current max, then we want to basically override it. So we're doing basically upsert temp first set, and we want to set the digit to be the new digit and index to the current index. Okay. But because we started trading over like in whatnot, it won't work. We need a proper range. And this range, we just need to make sure that it's one less than the full range, because for the first digit, we cannot find that one there. So we should basically go over indexes. So basically we can do from 0 to, and in this case, it will be bank length -1, because bank length will be, let's say, 10 characters, right? And this will be all the way up to, but not entirely, so it'll be up to 9, but that still will reach the 10th character, so we need to still decrease it by 1. So this should kind of iterate over all of them, hopefully. And therefore, this won't be a digit, this will be current index. Okay. So this is the current maximum, and let current digit is let's just call it digit. Bank, and we can access the index. All right. So we extract a digit, then we check if it's larger, and also if reached digit 9, there's no need to scan more, because this is already a largest digit, right? So if digit is 9, then we can somehow break. I think we have a way to break it, right? And that should break the loop. Let's see if we have something like break. break. We get for loop. And if number is this, break. So within if, we can just break it and we'll call it a day. Perfect. So that's exactly what we needed. And that should leave us with basically the largest digit and what is its index for the first digit. Yeah. Beautiful. I think it's gonna work. So let's just, after this for loop, after this for loop, why is it adding this? Tab just adds that, huh? Weird. So after this, we simply do something, we need to return some kind of value. So let joltage is, and we're gonna do something like, we want to convert to string the current digit. So again, we need to get the first digit. Okay. And that's gonna be, this will be first digit. And then we're gonna add, for now, just 0 at the end. And this should give us some kind of idea. So do we put any semicolons at the ends of things? I think so. Okay. Why are those so much notation for no reason? Okay, and let's write it all, copy it, and I copied everything. So voltages, and I guess we can't use the number 1. So we're gonna call it first digit. So let's actually fix it here. First digit. And we do first digit. There we go. I think that's gonna work. For the thing, it should work. Let's see what happens. Couldn't write to read-only transaction. Oh, I see. I see what's going on. So currently the problem is that we started a map here. Where over voltages, we were just mapping and we're like, we're doing stuff. And because we're inside a map, we cannot we cannot write to the database because reasons. Okay. So that means that we need to replace our map here with just a for loop. So let's try to do that. So let's do for, and do we want to index over them? I think we should index over them so that we can then later recreate the order. Or does the order matter? No, the order doesn't matter. As long as we add up the voltages, addition can be reversed. We don't need to order anything. So we'll just write down the voltages to a database. So for bank in battery banks. Okay. And that's it. Replaced. At the end, we just need to do whatever, create voltage and new voltage, and set value is, and we just added voltage, but this added is as a string, so we want to convert it to integer again. Okay. And therefore our result will be select. What was the addition that we had in last? Because this is pretty much the same thing. Sum of value from joltage. Just sum up all the joltages. We can even take this and kind of clean up before we do anything. So temp and joltage. Okay. And therefore, right. Yeah, it's all good. Therefore, we can just replace this whole thing. Ah, we got a problem here. Why is that? Oh, we don't need this thing because we're not inside the map anymore. So we just grab this, run the query, and okay, it summed things up. Didn't break. So we can go and look in the Explorer. We have our temp, which is the first digit. We never wrote index down, so, and we never updated the digit. Why is that? What happened? For each bank and battery banks, okay, we observed the first element and the second element, okay. Then for each bank's length, we go from 0 to something. The current max, select value digit from only temp first. Yeah, the digit. Okay. Now we grab that digit, which should be fine, the current index, which is starting at 0. If digit is larger than the current max, which should have been 0, we upsert it, and we actually set the current index. Okay. If reached the digit 9, then do something. So something is not going right here. Well, we need to finish soon, so I better solve it quick. Yeah, first digit. It's all just nothing. It's as if we never saved it. And we don't have a single situation where we would, like, at the end, I mean, we got values, right? So why is this at the end? Do we have like a last number that's like nothing? Hmm. Let's just grab the battery banks and just see what happens. Because I have a feeling there's something silly going on. Like, what is the last battery bank? Return battery banks. Run the query. And at the end, we have first bank all the way, tons of banks. But all the way at the end, we have an empty bank. That's what's going on. Because we have like extra empty line. And that's it. Okay, I can live with that because that means that, you know, we're still just by default saying, oh, this is 0. We couldn't find anything, we didn't iterate, we just do 0 plus 0, which and converted to integers will be 0. Literally nothing happens, no battery. Okay, so we can live with that. It added up all those digits. So now the cat is approaching. Okay. All right, so let's do something similar for the second digit. It should be relatively simple. So we can do another for loop. Let's just do it here in our editor. So we're gonna go for the other digit, but this one will be a little bit simpler because we don't need to keep track of the index. Because what we want to do is we create again current index, but instead of going from 0, we need to go from the currently maximum index or whatever. So we're gonna say that before we run it, we're just gonna say, hey, not current maximum, this will be first or whatever, first index, okay? We get it from the index of the first character, our first digit, whatever, and then we can basically say go from first index +1. Let's just do +1. Now let's just surround it, and then we go to the end, which is just bank length, okay? Because we don't want to skip the last digit anymore. So the current index is this. So now again, we want to find the current maximum. So not first, second. Did we name this second properly? Yes, we did. Okay. So basically, we take the digit from the second and digit from the bank at current index. That's good. The digit is larger than max. Absurd temp, but second. We don't write the index here, so we just have this very simple query. We can actually join them. And if we reach digit 9, there's no need to scan more. And we break, and that's it. So we have our first digit. Then we do our second digit. And this would be from second. And we're just gonna do literally the same thing here. Paste, but this will be our second. And that's it. Save it all. Let's paste it here. What happens when we run it? We got some kind of results, so that's good, right? We got a result. What we can do now is actually change our input to the one that was given as an example, okay? We had this input. This was our example input. Whoops. Okay, this is our example input. So let's go in here and I'm just going to replace it here. Whoa, wires. So annoying. One tries to select and just scroll around like crazy. Paste. Ah, there we go. That's why it was extra character. Okay. Run it and see what happens. The result is 357. And is that correct result? 357. There we go. So if we're gonna undo this thing, we can actually put the quote here at the end, run it again. This should be our result. We paste it here, submit. Answer is right. Let's just take a peek at part 2 to see if I can do it like in 5 minutes. If not, I'll need to finish. I need to go and pick my wife up. All right, so let's see. The escalator doesn't move. The elf explains that it probably needs more joltage to overcome the static friction of the system and hits the big red joltage limit safety override button. You lose count of the number of times she needs to confirm yes, I'm sure, and decorate the lobby a bit while you wait. Of course, Now you need to make the largest joltage by turning on exactly 12 batteries within each bank. The joltage output for the bank is still the number formed by the digits of the batteries you've turned on. The only difference is that now there will be 12 digits in each bank's joltage output instead of 2. Oh, okay. And hello, coolest possible name. Are you programming in a database? Yes, I am. By writing that kind of query, which feels just straight up like a normal programming language. Just with some specific limitations, like when we're iterating over things, we need to actually write to the database because we can't override variables. Like, change the number of the variable. Once you set it, it's set in stone. So we need to save to the database and then, read it. And at the end, to sum all the joltages, we just, hey, run the query, summarize it for me. Yay. Great. So that's that. So now this second part, it'll be 12 digits in each bank's jolted in output instead of 2. And my cat wants to play with the shirt. Great. Okay, so in this example, now the joltages are much larger. In this thing, the largest joltage can be found by turning on everything except some ones at the end to produce this. Okay, I see. The digit sequence. All right, so this shouldn't be too bad of a change. And coolest possible name says it looks cursed and cool at the same time. Yeah, kind of. So, okay, the only difference is that we are basically doing different number of those digits. So right now in our code, we have this kind of separation, right? Where is it? For each bank, we're basically saying, hey, we keep track of the first digit, keep track of the second digit, and basically do the query for the first one, do the query for the second one. But this could be kind of repeated as well, like no big deal. And because we are tracking some kind of yeah, I think I can bang it out in 10 minutes. All right, so instead of just hard coding the first and second digit, let's make it where the database will kind of keep track of those indexes just in one spot as an array. And that's it. Oh, you're CPN. Okay. Oh, that's right. You still have the same profile picture. You just keep changing names. Now it's CPN, of course. Awesome. Welcome back. All right. Yeah, I'm kind of in a hurry now because in 10 minutes I need to go and pick my wife up. So, yeah, I want to finish the third day actually this time. So, all right. So instead of 1 and 2, what if we have one object that we keep reading and writing to? And that's it. Yeah, so let's do something like so first of all, after our input, let's do something like let active batteries is 12. Okay, so this is how many batteries we need to activate, which will be 12, and therefore when we create this, we can just create one object, which will be temp whatever bank. Okay, this will be our bank that we keep track of. And we need to set basically digits, which will be an array. Okay, so we need to take from 0 to what the hell was it? Active batteries. Okay. And we can actually just convert it to an array. Okay, there we go. I think this will be fine. And so that's digits. And we can do probably the same thing for indexes. And the only thing is that we need to fill those indexes not with a 0, although we can probably do it with 0 because the moment we start tracking, the first number will be always larger. So we can leave it as zeros. There we go. We have 2 arrays of those numbers. Or is it? Because this is going to be a range, so not really. Let's just look at arrays quickly, because I believe... First of all, if we go to data types arrays, we can do this. Sets, adding arrays, mapping and iterating. Yeah, that's not what we want to do. We want to create a map, array of X elements. So database functions. SCPN says, I didn't change the name. YouTube switched to displaying handles of names. Oh, okay. As you can see, I haven't been streaming in a while, since actual Zig streams, which I want to return to, but time is constrained. My constraint at this moment. Array functions, okay? I recall that we have something like fill. Fill's an existing array of the same value. That's one, but wasn't there a second one? Certain item. Logical and matches, prepend, push. Creates a number array from a range, start to end. Okay, so that's not what we want. So we're just going to fill. How about that? Because we just created an array of X elements. Where's the fill? Okay. So we take this and fill it with 10, right? There we go. So we do fill with zeros for digits. Okay, and here will be fill with -1s for indexes. And that should be it for this thing. Okay. All right. Okay. So let's just do let battery range, and we're just gonna say that this is our range. Okay, oops. And therefore we can do this. Battery range. And therefore, before we go on with this, we need to basically iterate over all the ranges. So for, and let's call it battery index in battery range. Okay, so these were the indexes that we reach out to when setting everything. And then we can basically copy this one and paste it here. Let's indent it properly. And let's call it iterate over each battery in the bank. We need to find a digit for each. Okay, and then we need to find a digit for it, right? So this was the finding digit for the last one. I mean, for the first digit so far. And we were doing that, we need to add that offset at the end so that we still have enough room for all the other batteries. There was just 2 digits, so we had offset of 1. So here we need to change it that this is minus the, what is it? Active batteries. And that needs to be decreased, so we're going to do +1. Or, huh? Yeah, +1. There we go. Because we have a little bit different math. Okay, all right. I think that should be it for this. I'm just kind of quickly modifying the existing thingy. So now how can we set a specific index in an array? I think we can do, we will need to do something like get the digits, set something or whatnot and whatnot. Unless we can just do a quick update. Merge patch. Because I want to figure out how can I update just a specific index of an array, which is a field. Skills equals blah, blah, blah. Unset. Conditional, nope. We have the content. We have replace, nope. Merge. So specifying the full record. No, I don't think it's that easy. We're gonna go with simple root for now. And we're gonna basically try to, like, before we save anything or whatever, we're gonna need to do stuff. So we need to get the current maximum. So let so be digits. And that's gonna be, I could just create a separate records too, no big deal, but we'll deal with it. So be bank digits is, yeah, select value bank digits. Digits from temp. What was the object of it? Where am I reading? Bank. Okay, so this is all the digits. And therefore, from there, we can read that the digit is bank digit. Wait, that's the current digit. We need to let current max is bank digits. And we need to access the, what is it? CPN says, I'm dabbling into Odin. It's now my second favorite programming language. Okay, good for games as far as I know. Never tried it, but I'm understanding it's pretty cool. Has really nice opinion. It's just more specialized than Zig, I think, right? And it's moving a little bit slower too, I believe. Current max will be bank digits, and we just take the battery index here. Okay, so the digit is the one from the bank. Whatever the bank was up there. Okay, yep. And if the digit is this, and then we need to update. So the way we update is we let updated digits is And we need to figure out how to update digits, right? So do we have something like set or whatever? There is functions, array functions, and combine, complement. Is there replace or something? Aww. This little guy wants to snag a lot. Alrighty. It can go down. Let me just send a message to my wife. And where is it? Slice of an array. Swap to items. How the hell was it where I was able to set something in an array? I don't map over the elements to replace it. That's kind of silly. Add is to access. Ay, ay, ay. Arrays. Return a first, return index 0. Yeah, we can access them. But how do we set the elements? Set employees is this. Mapping and filtering on arrays. Huh. To be honest, I'm not sure how to set a very specific item on an array. So we're gonna do it in a ugly way that reminds me of JavaScript. We're just gonna map over the elements, but can we map with an index? That's the question. Where is map? We have this value, map. I thought we had index. Yes, map with an index. There we go. Oh boy, that's gonna be ugly. So we don't even need to update the digits. Oh, let's do it. It will be the bank digits, map over them, and we have digit, comma, index, right? That's how it was. Digit and index. There we go. We just need to make sure these are variables. Whoa. And how do we map it? Basically, if let me do it this. Let result is if index is, oh no, now we don't have access to that. How is adding something to an array so difficult? I don't get it. What the hell? Screw that. I'm not doing everything in one element. We're just gonna freaking add a bunch of elements, all right? So basically we had here for each battery bank, right? We still have the battery range, that's good. But instead of having this kind of one bank for everything, we can simply do something where we iterate over each battery bank in the battery, each battery in the battery bank, right? And we basically set it here, okay? We have our bank. We just need to change the number, which was type thing. We created that this is a temp And then we say battery index. Okay. And this is gonna basically create a record for each battery. And we can set that the digits is 0. Oops. What just happened? Undo. And this one will be -1. Okay. Current index is from here to here. Bank digits, we don't need that anymore. Current max is basically this. So let's actually do, whatever, battery digit ID is this thing. We put it here. This can be basically replaced with this. Okay, okay. And then current max will be select value digit from only battery digit ID. Okay. We just need to make sure that this is digit index, all singular. There we go. So digit is this, blah, 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 and of the digits, we don't need this. So we just need to insert it where the, what is it? Battery digit ID is set to digit is this is the current index, and that's it. I reached digit 9, there's no point, and I hope this breaks only that loop. And that should do everything until the last character, right? But this should be decreasing, not being always the same. Because this is the active batteries. So bank length minus, this should be decreasing. So right now is plus this. Plus 1. Active batteries minus battery index. Okay, -1. Something of this sort. That's what my intuition tells me. And therefore, this should calculate it for each one of those with remaining numbers. And the other thing is that we need the previous ID. That's less easy. Because the starting point needs to change depending on the index of the previous battery thingy. So, okay. We can do this. We can do this. So this is battery digit ID that stays, but we can do let previous battery digit index. And Ricky, CPN says you're cute. Yeah, he's just sitting right in front of me. I guess he likes the body heat. Okay, so let previous battery digit index is if battery index is 0, then we're gonna return -1. Okay. Else, we need to basically fetch it. Oops. So we're gonna do it in a way very similar to the other things. So we're gonna do select value index from only, and we're gonna copy this thing. Oops. Come on. I'm gonna copy this thing. Gonna paste it here. And this is battery index -1. Okay. I know this is not the most fun to read, but yeah, we need the previous battery digit index to have as a starting point here, which will be previous battery digit index. Someone tells me there will be like million syntax problems here. But okay, so at this point here, we should have all the data saved. And at the end, we just... What the hell is this? So this is that loop, right? We don't need the last one anymore because that's already automatically taken care of. And first index, select value from here, second index. Wait, what are we doing here? Oh, that's the second digit completely separately. Let's ignore that. This should take care of all the digits. We just went through all of them. And instead of doing this, we need to kind of iterate over them. How the hell do we iterate over them? We could kind of go over them one by one, but maybe there's an easier way. And yeah, let's do that. Whenever we create them, okay, we also set battery index is battery index. There we go. And when we update them, we also save that. There we go. So that means that we will be able to do a query to get all the digits, right? So we can do let digits is, and we do select whatever for now from, and we do, let's call it actually battery instead of calling it temp. We battery, and the same thing goes here. Okay. So we select all the batteries and order by field battery index. Okay. And what do we need to select from them? A digit. Okay, so these are our digits. Now we need to basically calculate the joltage. So let joltage is digits. We need to map them where each digit is basically, we need to convert it into a string, right? So we need string of digit. Okay. And then we can join them with an empty string. And that should be it. I have no clue what I'm doing. Absolutely no clue. Let's just put it here. We have all this, and let me just quickly glance if we have something that looks wrong in the first place. But I don't think so. So let's just grab the test data from here. The result should be much larger. Wow. And we'll be adding them together, right? So instead of saving them as integer, let's do decimal. And therefore, it'll be, again, a little bit more safe for adding it up. Okay. So now, just for this tiny input, wow, this is gonna be something. Just grab this. Wow. This is slow. We paste this here, okay. And what is the output? Problem, of course. Unexpected token, expected delimiter, 54. Oh, because we don't have this. Is that it? Missing order idiom, battery index, and statement. Wait, how is order by? Should be. Order by. Field. Something. Examples. Table order by. These are not examples, these are just random thing, but ascending. Missing order idiom. Statement selection. Oh. That's the problem? I think so. So we do digits and we map them where we say result. Although I don't think we need to map it, we just extract the digit. Something like this. Token and identifier, expected kind name, 57. Set value is. We ended this, we ended that. Create jolted set value is this. Decimal. Okay, progress. Now we have the actual execution going wrong. So let me just end with the last 4 rows. And I think we'll need to unfortunately stop. Because, yeah. Expect a range value of integer but found none. That means that wherever this is the current max, is not getting it. Battery index ID, we saved it, but current index, where do we get current index? From this, so that's fine. Yeah, something's weird. Don't know which way it's what. Yeah, we'll debug it next time. All right. I'm gonna just save this, push it, and well, I already started modifying code for the second part. I'll be fine for both. Where is it? This is the input. Oh, I didn't save it at all. Okay, sure. Start solving. Whatever. Complete part. Whatever. Day 3 part 1. Part 2 incomplete. Bam, bam. It's pushed. All right, we've got all the code. Everything should be in place. So, yeah, I'll see you probably tomorrow. We'll see how the time goes. A little bit, few busy days. So, we'll see how it goes. So, thank you, CPM, for joining. Thank you, everyone else, for watching, and see you around.